Rational equations, you just need to set it up for yourself this time. Okay, so this week, this is our last section in chapter 8. So this week, Thursday, will be your test for chapter 8. Okay, this week, Thursday, is your chapter 8 test. Chapter 8 is only 3 sections. It was 8.1, 8.2, and 8.6. Okay, so this is the last one. It's on mixture, distance, and work problems. They're all pretty much the same. And you're doing the same process. You just have to set it up this time. So, we're paying attention now. Okay, so the weighted average is a method for finding the mean of a set of numbers in which some elements of the set carry more importance or weight than others. Many real-world problems involving mixtures, work, distance, and interest can be solved by using rational equations. You need to focus. So, my first example here, so what we're doing is setting up the rational equation and then solving it. Okay, we're solving it just like we were the past few days. Okay, so example 1, Jimmy adds 65% fruit juice solution to 15 milliliters of a drink that is 10% fruit juice. How much of the 65% fruit juice solution must be added to create a fruit punch that is 35% fruit juice? Okay, so we have 65% fruit juice solution. We had originally 15 milliliters. That was 10%. Okay, so this 15 milliliters, and this 10% are talking about the original solution. Okay, now Jimmy was adding 65% fruit juice. Okay, so this is what we're adding. Okay. Now we want to figure out how much of that 65% fruit juice solution, so we're talking about the milliliters. How many milliliters of that 65% do we need? So that's going to be your variable. Okay, so that's what you're looking for. And we're going to create a fruit punch. You need to pay attention, please. You need to create a fruit punch that is 35% fruit juice. So here I have my fruit juice. The original, we had 10%. How would I write that as a decimal? 0.1. Or 0.10 is fine too. And we have 15 milliliters of that, right? So I'm going to multiply those. Okay, so these are your originals. 10% to 15 milliliters. Okay, the milliliters, as in a liquid. Small? No. Your total is talking about how many milliliters of solution. Okay, so total, for the original, you had 15 milliliters of solution. Now we're adding, so we want to look at what's being added. Well, we have 65% fruit juice. Okay, again, I want to change that to a decimal. Okay, so that would be 0.65. Now, we don't know how many milliliters are being added to that. Okay, that's what we want to find. Okay, so that's our X value. There's way too much talking. Okay, so we have a 65% fruit juice solution. We don't know how many milliliters it is. Now again, your total here is talking about the milliliters that's being added. Again, we don't know what that is. Your new solution of that fruit juice, okay, is adding these two together. Okay, so we'll add 0.1 times 15 plus 0.65x. Again, we're adding together our total milliliters. So we have 15 plus x here. Now to figure this out, we're trying to create this 35% fruit juice. Okay? So we want, okay, the percentage in fruit juice. Okay, that'll be equal to the amount of fruit juice over the total solution. Okay, so we're trying to make this percentage of fruit juice. The amount of fruit juice is what we were doing here in that top row. That's the amount of fruit juice. That's why it's labeled as fruit juice. Your total solution is what we're doing in this bottom row. We're finding the total amount of milliliters. Okay? So your percentage that we want to find was this 35%. Now I want to write that 35% as a fraction now. Okay, so that would be 35 over 100. Okay, that's equal to your amount of fruit juice is what we found in this box here. Okay, so we have 0.1 times 15 plus 0.65x over, again, your total solution is talking about the milliliters, so 15 plus x. Okay, so we want to solve this equation. So we can find our least common denominator. Okay. So to do that, we need the LCM of both of your denominators. Well, my first denominator here is 100. My second one is 15 plus x. So it would be 100 times 15 plus x. Now with that LCM, I need to multiply all my fractions by it. Okay, so we'll take 100 times 15 plus x. That'll be multiplied by 35 over 100. Then doing the same thing to this fraction here, we have 100 times 15 plus x. And that's multiplied by this fraction 0.1 times 15 plus 0.65x over 15 plus x. Now I do that so that I can cancel out my denominators. Okay, so I can cancel out this 100 and I can cancel out this 15 plus x. Okay, so what I have left here is 35 times 15 plus x equal to 100 times what?
I'm just confused because we got the answer that we just got is the same as the top, but why don't we just cross out the top?
Cross out the top.
Because the top answer right there is the same as the bottom answer that we just did.
What is this strap?
This one?
1.1 and then 15 in the parentheses, whatever that top one. Yeah, it's the same one at the top, isn't it?
Yeah.
This part?
I understand.
Up one, that, and then the
I'm
one
just thinking that would
Yeah.
have
It's
to
the
be
same. So why do we have to do that whole? Why did we roll it?
I rewrote it because I'm multiplying by the LCM. All right, once I'm done multiplying, okay, now I can distribute. Okay, so I'm going to distribute 35 to both numbers here. Okay, so we have 525 plus 35x. Okay, I can multiply 100 to this 0.1 and this 15. So you can multiply all three together in a calculator. And you'll get 150. I need to multiply 100 by 0.65. That's 65. And I need to keep that x with it. Okay, so subtract 150. Okay, that's 375 plus 35x is equal to 65x. Subtract 35x from both sides. So we have 375 is equal to 30x. Divide both sides by 30. You should get x is equal to 12.5. No. Okay, so the amount of fruit juice that you need to add would be 12.5 milliliters. Okay, so of that 65% solution, you need 12.5 milliliters of that in order to create 35% fruit juice. Okay, so this is your first type of problem that you'll get with percentages. Okay, the next one has to do with distance, rate, and time. Okay, so the formula relating distance, rate, and time can also be used to solve rational equations. The most common use is distance is equal to rate times time. Okay, so distance is equal to rate times time. However, it can also be represented by rate, okay, is equal to distance over time, or time is equal to distance over rate. Okay, so we could use those to help us set up. Shh, there's way too many conversations happening. we can use these to set up certain rational equations. So in example 2, you have the speed of the wind is 20 miles per hour. Okay? Your wind speed is 20 miles per hour. If it takes a plane 7 hours to fly 2,368 miles round trip, we want to determine the plane's speed in still air without the wind. Okay, so right now it's going with the wind and against the wind. So here I have your table. We need the time with the wind, the time against the wind, and then the total time. So since this says round trip, okay, that means there and back. Okay, so getting to their first destination, right, would be this distance divided by 2. Okay, because it's a round trip. So halfway they're going with the wind, halfway they're going against the wind, because the wind's going to be going in one direction. Okay, so that distance would be 1,184. Okay? Now time, again, if you look up here, time is equal to distance over rate. Okay? So time is equal to distance over rate. And in each of these boxes, I'm trying to find the time. So my distance with the wind and my distance against the wind are going to be the same. They're going to be this 1,184. So half with the wind, half against the wind for that round trip. Okay. Now your rate, okay, your rate is how fast you're going. Okay, we don't know how fast the plane's going in still air. All we know is that when you're with the wind, okay, it's going to add that 20 miles extra to it, right? So I don't know my still air rate, but I know when I'm going with the wind, it'll add that 20 miles per hour extra. Now if I'm going against the wind, I still have my still air rate, except now I'm subtracting 20 miles per hour. Now your total time was already given to you. It takes 7 hours for that plane to fly round trip. Okay, so your total time would then be 7. Okay, so now to get that total, you can take both of your times, since distance over rate is equal to time, you can add those together and you should get 7. Okay, so we're going to take 1,184 over r plus 20 and add on the time against the wind, 1,184 over r minus 20, and that should take 7 hours. Okay, so now again, to solve this, you need that least common denominator, or the LCM of all of your denominators. Now this 7 would be over 1, okay? Just make sure you're remembering, if it's a whole number like that, it's always over 1. So trying to find that LCM, okay, I have this r plus 20. I also have an r minus 20. Okay, those are your two denominators that you need. And you can't factor them, so you're just going to multiply them both together. That will be your least common denominator or your LCM. So now I can multiply each fraction by that LCM. Okay, so we'll take r plus 20 times r minus 20, multiply it by 1,184 over r plus 20. Same thing with that second fraction. Okay, so we have r plus 20 times r minus 20 multiplied by 1,184 over r minus 20. I still need to multiply the last one by that LCM as well. So r plus 20, r minus 20 times 7. Okay, so now what I can do is cancel out your denominators. So we have r plus 20 and r plus 20. We have r minus 20 and r minus 20. And that's all I can cancel out. However, that did cancel out all of your denominators. Okay? So now just rewriting this problem. 1,184 times r minus 20 plus 1,184 times r plus 20. Okay, that's equal to 7 times, if I were to FOIL this, okay, you do need to FOIL it, your middle terms would cancel out because it has that plus and minus in it. Okay, so once I multiply everything through, I should get r squared minus 400. Okay, and I'm just going to do that right away. Okay, now I'm going to distribute. Okay, so I have 1,184r minus, I gotta figure out where my number is, 23,680 is 1,184 times 20. Okay, then I'm adding 1,184r plus again that 23,680. Okay, that's equal to, I have to distribute this 7 to both terms, so I have 7r squared minus 2,800. Now if I look on this left-hand side, I have this minus 23,680 and plus 23,680. So those will just cancel out. Those equal 0. Okay. I have to add together my 1,184r, 1,184r. Okay, those are your like terms. That will be 2,368r. Okay, that's equal to 7r squared minus 2,800. Now once I get to this point, I need to get everything on one side of the equation because I still have an r squared and an r in my problem. Okay, so we want to set it equal to 0. So that means I'm subtracting 2,368r from both sides. Okay, so I have 0 is equal to 7r squared minus 2,368r minus 2,800. Okay, you can't factor this. Do you remember what you have to use if you can't factor? No, that's not it. You just leave it? No. Okay, you have to use the quadratic formula. If you can't factor it, you have to use the quadratic formula. Okay, so I'm going to rewrite it up here. Your quadratic formula is the opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, you're just plugging those numbers in. You got that copied down? Okay, so your next step is to take what you found here and plug it into that quadratic formula. So your 7 is A, B is negative 2,368, and C is negative 2,800. So you want to plug those terms into that formula. So I'm going to try and make room over here on this side. Okay, so we're trying to find R. We need the opposite of B, so 2,368 plus or minus square root. We need B squared minus 4 times A times C. Yeah, it's going to get real small. You can honestly plug this all into a calculator and you should get your answer. Over 2A, A is 7. Okay, after you do everything underneath that square root, you should get a large number. So 5,685,824 is underneath that radical. Again, that's all over 14, so I just multiplied 2 times 7 there. Now when you're solving for R here, you have this plus or minus in the quadratic formula. You're not going to do the minus 1, okay? That would mean your plane's going a negative speed, okay? And right. So you're just going to do the positive 1 because your plane has to be going a positive speed. No, even if you're going reverse, you're still going a positive speed. Speed is always absolute value. Okay, so you should get R is equal to 339.5. Okay, that's miles per hour. That's how fast that plane would be going in still air. Okay, so those are your first two types. So again, the first one was your percentages and solutions. The second one is your distance, rate, and time. Okay? The last one is the easiest, to be quite honest. Okay? It doesn't even take as long. Okay, so last one is just kind of their rates and then how they would do them together. So it took Anthony and Travis 6 hours to rake the leaves together last year. Okay, so it took them 6 hours together. The previous year, it took Travis 10 hours to do it alone. How long will it take Anthony if he rakes them by himself this year? Okay, so for each of these, we have how many yards they're doing per hour. Okay, each one is yards per hour. All right, Travis is by himself. Okay, it took Travis 10 hours by himself. So he did 1 yard in 10 hours. Together, Anthony and Travis took 6 hours. So they did 1 yard in 6 hours. Now, if we're trying to find Anthony's rate, we need 1 yard, and we don't know how many hours. So that's where our variable is going to go. Now, in order to get their yards together, we need to add their yards separately and set it equal to their yards together. Okay, so we'll take Anthony's rate, so 1 over R, plus Travis's rate, 1 over 10. And that should equal their rate together, which is 1 over 6. Okay, so again, when we're solving a rational equation like this, we want a common denominator, or the LCM of all three. So we have R is just R. 10 is 2 times 5. And 6 is 2 times 3. Okay, this is me finding the LCM of all three. Okay, so for LCM, I have 2 and 5 from that 10. Moving on to 6, I already had a 2. I still need a 3 and that R. Okay, so we have 10 times 3, that's 30 R. Okay, so I'm going to multiply each fraction by 30R. Okay, so I multiplied each fraction by that LCM of 30R. Now I can cancel things out. So I can cancel out these R's here. I have 30 over 10. That's just 3. And I have 30 over 6. That's just 5. Okay, now just rewriting my problem. I still have 30 here. Plus, I have this 3 and this R left. So we have 3R. And then I have this 5 and this R left. Okay, I want to subtract 3R from both sides. So I get 30 is equal to 2R. Divide both sides by 2. And R will be 15. Okay, so it would take Anthony 15 hours alone. Okay, so you're setting up these rational equations and you're solving them just like we did before. Okay, get your LCM and least common denominator. Multiply all three by that LCM. to cancel out the denominators, and then solve from there. Okay, so again, chapter 8 is all the same thing over and over and over again. So you should have the assignment on that tan piece of paper that you grabbed. Those 3 problems are similar to the ones that we just did in class. Okay, so the first one is like our first problem. Second one is like our second problem, and third one is like the third problem.